Rembrandt helping us out here. Brought my friend. This is my friend Ross. We learned about circles in this unit. The whole unit is devoted to circles, and this section is devoted to tangent lines. Now, why did I bring Ross? Because he's a tangent. There's a pun in there. Someone in K-Town, please explain that to Sully. What is a tangent line? Well, a tangent line is a line that intersects the circle at exactly one point. You can only intersect one time. Remember, lines go in both directions forever. So what you're looking at is a line that kind of comes through and touches only one time. That is a tangent line. It can only touch the circle once. Okay, can it go through the center of the circle? Well, no, that's impossible. You're going to touch it twice. Okay, so tangent lines can be on any side of the circle. They can look this way. You can move it up like this and then say, okay, well, that's a tangent line right there. But it can only touch at one point on the circle. Now, what do we call that point there? Well, let's look at our keywords. Tangent, that's the line itself. Point of tangency, that's the point where it intersects, the one time where it intersects. And then radius, we're going to have to know what that is. That goes to the center of the circle. It's halfway across. And that brings us to our first theorem. There's basically two main theorems that we have to get control of right here. The first theorem and its converse. All right, so what does the first one say? It says if a line is perpendicular to a circle's radius, then the line is tangent. All right, so look at this. So here's a line. If I tell you that this angle is perpendicular, if I tell you this is a right angle, then you know the line is tangent. It's that simple. The converse, if you have a tangent, then you know that it's a right angle. All right, so that's going to play out in several different ways. Okay, tangent theorem number 2. If two tangent segments share a common endpoint outside the circle, those segments are congruent. All right, so remember, you're going to have to pause the video and write this down. I know we're going pretty quick here. But what does this look like? Okay, tangent theorem number 2. What does that look like? Well, if you have a common endpoint and two tangents. All right, so here's the common endpoint, and we have two tangent lines to a circle. What does that look like? Do these look congruent? They kind of do look congruent here. There's congruent. That's congruent. That's what the theorem says. What else does it look like? No, the correct answer is an ice cream cone. Yes, that's right. Every time I teach this, I get a little bit hungry and my mouth starts to water. So if you hear some slurping, that's me. I'm sorry. But basically what that means is the two sides of the ice cream cone are the same. They're congruent to each other. So let's look at some examples here. What are we going to have to know here? What does it all mean? Well, we need to know the Pythagorean theorem. That's going to be our best friend. All right, so the question says, determine if line AB is tangent to the circle. Is it tangent? Well, it's only tangent if this is a right angle. That's what the first theorem says. If you remember, go back to theorem number 1. If a line is perpendicular, then it is tangent. Well, that's what we're going to use right here. If a line is perpendicular, we got to figure out if that's a right angle, so we can use our right triangle trig. We're going to have to figure this piece out right here. They only tell us the top part, which is 4. Remember that all the radii of a circle are congruent, so that must be 11 as well. So we're going to use converse of the Pythagorean theorem, which says if a squared plus b squared equals c squared, then it's a right triangle. So we're going to use that. A squared plus b squared equals c squared is 11 squared plus, that was a little weird, is 11 squared plus 12 squared equal to 15 squared. And remember, here's the right angle, so this is our hypotenuse. That's the one that has to go where c squared is. So is 121 plus 144 equal to 15 squared? I actually know that. That's 225. All right, so what do we get here? 265. Is 265 equal to 225? No, it's not. So this is not tangent. See how that works? So we're going to do the Pythagorean theorem. That was weird again there. And we're going to see if it works out. And if they are equal to each other, then say yes. But here, they're not, so we say no. Try the next one all by yourself. Go! Pause the video. Go! I really mean it. Pause it. All right, so hopefully you worked it all out. What did you get? Okay, when you figure it all out there, you get 12 squared plus 6.4 squared. That has to equal 13.6 squared. You got to add those two together. You get 184.96 is equal to 184.96. Yes! It's tangent. That is awesome. How about the next example? Find the missing segment lengths. All right, they're going to have to tell you that this is tangent. All right, so let's pretend they did that in my directions. All right, tangent. There's a T for that. So that means that this is a right angle. And let's call that x. And what about this? This is a radius. That's also a radius. All right, so that's going to be 12. I'm going to change color up here because now we can do the Pythagorean theorem. I get that weird little thing going on my screen. That means my computer's about ready to die probably. So do we get x squared plus 12 squared? Is that equal to, you got to get this whole hypotenuse here. Remember that's the hypotenuse because it's across from the right angle? That's 20 squared. All right, so is x squared plus 144 equal to 400? All right, when you solve it, you get x squared equals 250, what do we get, 6? Or x equals 16. All right, so x equals 16 here. That's the tangent. We found the length of the tangent. So the Pythagorean theorem is going to help us out. It's going to play a big part actually as we go through these different examples. So make sure that you know your Pythagorean theorem. All right, so how can we use this theorem with some isosceles triangles to find some missing angles? Well, let's see. This is the tangent line. So the tangent line is perpendicular. So we know that. That's always true. So that's going to be a 90-degree angle there. All right, what else can we figure out? We know this is 114, and let's see, this central angle, that's 114, and this one form a linear pair. That means that they add up to 180. Remember that? All right, so this has to equal 66. Because they equal 180. So 180 minus 114. What else can we get at here? Well, let's see. If these equal 114, then these, look, we have congruent radii there. This is an isosceles triangle that we're looking at. All right, so isosceles triangles have congruent base angles. So what do we have here? 180 minus 114. We already did that. That's 66. That's for these two angles there. If you divide by 2, you're going to get 33 for each one of these. Okay, so this is like a little puzzle. We're figuring it out. All right, so if this is 33, these are linear. These form a linear pair, so that means that this side has to be 147. We are almost done. All right, so now we're going to look at, I'm going to change up the color here, highlight it. Okay, we have a quadrilateral. Oh, look at that. And the quadrilateral, that is the ugliest screen I've ever seen. Quadrilateral. How many degrees in a quadrilateral? Remember n minus 2 times 180? Quadrilateral has 360 degrees total. It's basically two triangles. So what are we going to do? We're going to set up an equation. 90 plus 66 plus 147 plus this little question mark, which I don't know. That all has to equal 360. So let's math it out a little. So 303 plus x equals 360. All right, subtract 303 from each side. You get x equals 57 degrees. All right, so 57 degrees is the answer to that one. Do you think you can do one by yourself? Let's try this one. Now, I'm going to give you a hint. We got isosceles triangle. Isosceles. Go ahead, pause the video, do that one by yourself. All right, let's check our work. I'm going to go through it quickly. Here's the tangent line, perpendicular to the radius. All right, so that's 90 degrees right here. Awesome. Now look at the big triangle. Okay, the big triangle, what do we got? That has to equal 180 when you add them all together. That means that this base angle down here is going to be 40, same as this one right here. So we have 40 and 40, that's 80 degrees. The whole triangle is 180, so that means that this has to be 100 degrees. Okay, so for this one, you can call it x if you want to. X equals 100 degrees, and you're all done. Hey, that's easy enough. Let's do another type of example. What do we got this? Find the perimeter of the polygon. Well, this is kind of weird. Let's change it up and use a little purple here. Now look, what do we have? We have a point and two tangent lines. But remember, our second theorem said that if you have one exterior point, both tangent lines are going to be congruent to each other. So that means that this segment down here equals 8. All right, so we know that from this point to this point is 10. Okay, the blue line tells us that. So that means that this side must be 2. But we're going to use the same theorem again. That one must be 2. All right, so coming from this direction, if that is 7.4, this one up here has to be 7.4. And if this is 5.5 on the right, we get 5.5. They want the perimeter. Remember, perimeter is all the way around the outside. So the perimeter is going to equal, all right, here we go. We get an 8 plus 2 plus 2 plus 7.4 plus 7.4. See how this is going? Man, I could have made this easier by using some multiplication or something like that. 5.5 plus 5.5 plus another 8. Add them all together. What do you get? Math perimeter is going to equal 45.8. How's that? That's easy enough. Can we do that one? Yes, we can. 2 more and we are done. Done. All right, well, let's look at this. Solve for x. All right, so it's the same type of thing. What I want to draw your attention to first, we have 2 tangent lines. We have a right angle right here. We have a right angle right here. You got to be careful. All right, that means that we have right triangles. So if you have to, you can use the Pythagorean theorem. Okay, I can't do every single type of question for you, but I can do lots of them. But I can tell you that if you want to do Pythagorean theorem, you could. That won't help us here, though, because they just want you to solve for x. And what we can do here, this side and this side here, these 2 tangent lines, they're equal to each other. Well, if they're equal to each other, that means you can make a little equation. We're going to use algebra. 1 plus 3x is going to be equal to 2x plus 4. All right, now what? Subtract 2x from each side. Whoop. There it is. 1 plus 1x equals 4. Subtract 1 from each side, x equals 3. Done. Make sure they don't ask you for the tangent, do they? No, solve for x. So we got x equals 3 for that one. We're all done. How about the next example? Oh, by the way, we didn't use that number. Okay, they're going to throw extra numbers at you. And we're not going to use this number. What do we got there? A little x squared? Oh, man. You know what that means. We get x squared is going to be equal to, remember these tangent lines are congruent, so their measures are equal. We get x squared is equal to 9x plus 36. Guess what this is? Yes, ugly. So x squared minus 9x minus 36. Remember, you got to set it all equal to 0. Minus 9x minus 9x. Okay, minus 36 minus 36. That'll get you to this point. Here we go. The ugly x problem. Some of you still don't know how to factor. At least in my class, I know that because you come up with your packets. How do we do this? It's a times c. That goes in the bottom. So we get negative 36. Negative 9 in the top. All right, so how can I factor this thing? Well, what multiplies to 36? But it'll add and give you a 9 there. So I'm thinking, what do we got? Negative 12, positive 3. Is that going to do it for us? So we get x minus 12 and x plus 3. That'll equal 0. So remember, you got to put each one of these factors equal to 0. X is going to equal 12, or you're going to get x equals negative 3. All right, let's look at our 2 answers. We get x equals 12 and x equals negative 3. Are you tempted to cross that negative 3 off? Are you? Why? Because it's negative? Yes and no. I mean, we got to go up to our picture and look. If we get x is 12 and x is negative 3 and we plug in those values, do we get a negative distance? That's when you cross it off. If you plug a value in and it ends up being negative. All right, so the 12 we don't have to worry about. 12 squared, 144. Plug a 12 in there. It'll all work out for you. Okay, 108 to 36. But the negative 3, if we plug it in, negative 3 squared. Use parentheses if you're going to use a calculator, which is sad because you should be able to do that in your head. You get 9 on that side. How about over here? You get 9 times negative 3 plus 36. When you plug it in, you also get 9. That works out to a 9. All right, so the negative 3 is also a solution here. You have to check both. Now, if I plugged in that negative number and it worked out to be negative, I would just throw that answer out. But I can't do that here because both of them work. So we get 2 answers here. X is 12 or x can be negative 3. You need both answers to be correct. So double check both on your mastery checks. Guess what? That's the entire lesson. I don't think it's that difficult. You just need to practice it. We got a nice application problem involving space and Sully vision. So you're going to have to remember your Pythagorean theorem, and you're going to have to remember all your exterior angles and isosceles triangle rules and that kind of stuff. Hey, this is Mr. Kelly coming at you from Baumholder. Remember, it's nice to be important. It's more important to be nice.
So go away. I don't want to see anybody.
I know. I went to the tanning place, and the same thing happened to me. You have to let me in.
Really? Did you count Mississippi?
I had to get a picture of this.
I'll see you later.